analyze some sample data for our density lab. So in this lab, you had two cubes and you measured the length, the width, the height of the cube. So here's my data. I got 1, 1, and 1. And I used a different cube. This one wasn't in the lab kit. The lab kit, you should have a smaller cube. I tried a bigger one. So I measured the length, the width times height, and that's how I find the volume, right? Volume is just length times width times height. So let's calculate the volumes for both of these. So volume equals length times width times height. I got 1 times 1 times 1. Oh, it's a hard calculation. I don't even need my calculator. It's going to be 1 centimeter cubed. All right, so that's my volume, 1 centimeter cubed. And then I'm going to find the density, right? Density, we know density is mass over volume. So this is my mass. Again, I just tared my balance. I put the cube on the balance, and then I got the mass. So mass is 1.40 grams divided by 1 centimeter cubed, and that gives my density. My density is going to be 1.4 grams per centimeter cubed. And now what I'm going to do is go back to the lab and look up the table of densities, and I'm going to look for 1.4. So there it is, 1.4. So PVC has a density of 1.4, so I'm going to assume the identity of that solid is PVC. Now you might have a different cube in your kit. It might not be PVC. All right, so I got my density here was 1.4 grams per centimeter cubed, and the identity of it was PVC. Now they're asking, if I put this in water, do you think what I expect is to sink or float? And then later on, we're going to check that. Because the density here is greater than the density of water, so 1.4 is more than 1. Density of water at this temperature is about 1 gram per centimeter cubed or gram per milliliter. So I would expect that this guy would sink because it has a greater density. So let's do the same thing for this wooden cube over here. So you can see another example. Length times width times height. Now look at this. This time when I measured this, it wasn't really a perfect cube, and that happens sometimes with the with the wooden cubes. So if you measure length and it's not exact, it's not a perfect cube. That's okay. You can still approximate the. You can still do this. Find the volume with that. Great. So when I do 3.9 times 3.9 times 3.8, I got 57.8. Yep, 57.8. All right, and centimeters cubed. So I had 3 sig figs here all the way down, so I'm going to end up with 3 sig figs over here. So my volume here, 57.8 centimeters cubed, and you can see the mass is right here. So I just put that on the balance. So density is mass over volume, so I'm going to have 35.59 grams over 57.8 centimeters cubed. And then when I work that out, I got 0.616 grams per centimeter cubed. So now I can look that up in the table. Just go back over to my lab. 0.616. So oak wood is in that range. Right? 0.6 to 0.9 is going to give me oak wood. So I would assume that this guy is probably oak wood. Okay, so 0.616 grams per centimeter cubed. I think this guy is oak. And what I expected to sink or float. So this time it's less than 1. So again, density of water is 1 gram per milliliter, or 1 gram per centimeter cube. A milliliter is a centimeter cube. They're the same thing. So I would expect this guy to float, right, because it has a lower density. Right, so that's the first part. Those are regular solids where we just measured length times width times height of a cube. Now, if you have an irregular solid, that method's not going to work. We had to use volume displacement. So we dropped our irregular solid. You might have a pin, you might have a screw. Drop that into the water, and you have your initial reading of water, and then you see how much it increases. So my initial reading was 6 mils. And then when I dropped the cube in, it went up to 7.6. So it displaced a certain amount of water. I need to figure that out by subtraction. So I can just say 7.6 minus 6.0. That gives me 1.6 milliliters. So because it displaced 1.6 milliliters of water, that's the volume of my irregular solid, 1.6 mils. 1.6. Great, and now I have density. Again, density is just mass over volume, so my density is just going to be the 14.24 divided by 1.6. 14.4, 14.24 divided by 1.16 gives me 8.9 grams per milliliter. So I can look that up in the table. Go over here, 8.9 copper. Great, so this guy has to be copper. So it's copper. Oops, sorry, over here, copper and 8.9 grams per milliliter. And that's my calculation. And what do you think about this guy? Is he going to sink or is he going to float? He's greater than 1, so he's going to sink. Now, when you're looking up things in the table, you may not get an exact number. You may get some, just pick the closest one that you can find. And if there's not one in the table, email me, so we'll figure out what happened there. So sometimes when there's a lot of things that can go wrong, just let me know and we can figure it out.